not?
X-axis. Y-axis. What's interesting about the x value x sub 4? Oh, sorry, can I label this? This is a graphic equation y equals f of x. By the way, you guys, if I'm not clear, these are solid dots. In other words, I've got a domain from x sub 1 to x sub 5. What's interesting about the value of x, which is labeled x sub 4?
It's a local maximum.
What do you mean local? What the heck does local mean?
What is local?
There's multiple maximums.
What kind of maximums?
Local maximum?
Would you guys agree that x equals x sub 4, that is the maximum y value? Maybe no, right?
What, x plus 5?
X sub 5 is...
Oh, at x equals x sub 5, there's a larger y value. You're right. I guess at x equals x sub 4, it's not the highest y value.
Yeah.
But do you think I can find some open interval about x equals x sub 4 for which, over that open interval, x sub 4 yields the biggest y value?
Yes.
Then I think I'm going to refer to x sub 4 as an x value that yields a local or relative maximum. Because I can find some open interval about x equals x sub 4 for which the corresponding y value is the largest over that open interval. Do you think I can find an open interval about x equals x sub 3 for which the y value at x equals x sub 3 is the smallest?
It's the global.
Therefore, I would think of y sub, x sub 3 as yielding the local or relative minimum. Do you think at x equals x sub 2 I've got a relative max? I think the answer is yes. I think with my purple pen, I can create some open interval about x equals x sub 2 for which the y value at x equals x sub 2 is the largest y value over that open interval. Do you think I can find an open interval about x equals x sub 5 for which the corresponding y value is the largest?
No, it is
What do you mean, no? Why not?
because it's larger than any of the other y values.
Oh, that's irrelevant with my question. My question is this. Do you think I can find an open interval about x equals x sub 5 for which the y value at x equals x sub 5 is largest?
Well, you have one side that doesn't have any values.
That means I can't make a comparison. And since I can't create an open interval about x equals x sub 5 and determine whether or not the y value at x equals x sub 5 is larger than all the others, I guess the question is moot. I cannot possibly have a relative max at x equals x sub 5 because I can't create an open interval about x equals x sub 5 and compare the y value at x equals x sub 5 to the y values over the entire open interval.
So in a sense, are we taking the limit of that and figuring out if...
No, I'm not even going that far. That's too complex. I'm much more simplistic tonight.
Yeah.
So I think for that reason, at x equals x sub 5, I do not have a local or relative max. However, if you take a peek at my picture, I think the absolute maximum y value is at
X sub 5.
x equals x sub 5. I think the maximum y value is f evaluated at x sub 5. So I think at x equals x sub 5, I may not get a local max, but I certainly have the absolute maximum y value over the closed interval from x sub 1 to x sub 5. An absolute max is different than a relative max. An absolute max is, close your eyes, open them, see which y value is the largest. A relative max or local max is different. It's a value for x for which you can create an open interval, for which, over that open interval, your x value gives you the largest y value. Get the difference?
Yes.
Is there an absolute min in this picture?
X sub 3.
Oh, so at x equals x sub 3, that's the absolute min, but at x equals x sub 3, is that also a relative min?
Yes.
So relative maximums and relative minimums could be absolute max and absolute mins. But absolute maxes and absolute mins might not be relative maxes and relative mins. Do you see my point?
Yes.
So I need you to get used to these adjectives, local relative and the adjective absolute. There's quite a distinction.
Is absolute also global?
Yeah, as a matter of fact, if you don't like the word absolute, the adjective absolute, use the adjective global. It means the same thing. Absolutely. No pun intended. No, it doesn't. You guys are tired of talking. Can we take 10 minutes? Nabil?
I have a really quick question, which is
Yes.
like, why when you were doing that, didn't you get rid of r?
I don't have to. It's just a constant.
Well, yeah, exactly. It's 1. So can't you just get rid of it to make it simpler?
My apologies, I forgot that it was equal to 1. Yeah, we take a look at the thing. If you didn't know what R is, everything I have is written just fine. But if you know it's equal to 1, go for it, plug it in.
Okay.
Actually, when I wrote all this stuff in Nabil, I completely lost track that we knew what R was. I was just saying to myself, it's just a constant, whatever it is.
Oh, okay, alright.
What did you say we do after that very last part? Do we do something around over here?
Would you confess that we're not done? I mean, technically speaking, if you look at the question, we're trying to find the rate at which the depth of the water is changing, I think. Depth.
Take the derivative with respect.
What number is this?
25.
I'm so sorry, it's been too long. Look at the question. How fast is the water level changing? That means I'm trying to find dHdt. So our next step is to replace this d theta tt with an expression involving dH dt. So I've got yet again another substitution to make. I was just simply saying, you guys, take a break. Look at this relationship. If you differentiate both sides with respect to time t, you're going to get a dH dt. You're going to get a d theta dt.
Oh, and then we just
You just make a substitution. Absolutely. I just didn't take the time to finish it. I just talked my way through it.
How can you say R is a constant when R is changing as you're going down?
You know what? I don't think it is. Watch. In this picture, no writing. I think this water level is decreasing. I think these two sides are going to kind of crimp in. But no matter how small h is, I think these two sides here and here with my fingers, my hands, are going to still be the radii of the circle.
Okay.
I don't think those R values have changed.
Okay, say you have a horizontal radius from the top of the trough. Okay. And then say.
You mean from here to here?
Yeah.
Got it.
And then when you go down, the horizontal radius won't be the same.
I see your point, but that's no longer the radius. I'm saying this, if this squig line is the water level, the connecting the center from here to here, I still think it's a radius circle. And even if the h value is really, really small, I think this dimension right here, the length of this side, is still going to be r.
Doesn't the radius have to be the same all the way around?
It is, that's why I said it's a constant. Sir, watch this. Let me change the picture. Black pen. Let me make my picture really extreme. And if I had this face, and the water level really down here, is it not the case that this from here to here is still the radius of the trough? Well, I should say, radius is the cross-sectional slice of the trough. And so is this. But if the water level were really high, I think this length right here is still R, this length still R. I don't think it's going to change. So in my picture, the way I labeled things, that length R is not going to change no matter how theta or h changes. It's still going to be the constant R.
So even though the value might change, it doesn't matter?
The value of what will change?
The radius.
It won't. I think in these two pictures, this extreme picture right here, or this upper one right here, I think the water, no matter what the water level is, those two lines say it's still the radius of the circle. It's not going to change.
So you're saying that those two different lengths can equal the same thing?
You know what I think you're doing? I think you're doing this. I think you're thinking, saying to yourself, that's the radius.
Okay.
It's not. I think in my picture, that's the radius for that water level.
Okay.
And if the water level were really low like this, I think that's still the radius. And I think you're concentrating on this horizontal length right here. And I'm not. And I even identified that dimension.
So to finish the problem, all we do is replace the expression involving d theta dt with the expression involving dH dt and solve for t, right?
And then we're done. No, not solve for t.
Solve for
We're solving for
dH.
dH dt.
Oh.
Because we're trying to find out how fast the rate that water level is decreasing.
Yes.
Yes.
Sorry, I lost
See
it.
a negative then.
It will be a negative. If it's not a negative number, we're in trouble. It better be a negative number.
I have a question. When you try and derive for h, there's a theta and a d theta dt. So what do you do about that?
Oh, that's fine. Actually, you don't end up with a theta, you end up with a sine of theta.
Well, yeah.
But
Huh?
did I walk in the right class?
Well, what are we doing?
Is it 1 minus
Are
cosine?
we,
Or cosine theta over 2? Or cosine squared theta?
Thank you. By the Pythagorean identity.
Okay.
Very good.
you just did the Pythagorean identity.
Oh. Wasn't sure where we were going with that.
Because we know something about the cosine thing.
Yes, we do.
Very good.
Alright. So as I said, take a very quick break.
Alright.
Come on, back.